Let t be any real number and let p be the terminal point on the unit circle determined by t. We then define each function as follows. So the first three, which are typically the most important three of the trig functions, are sine, and that is the y value on the point here on the unit circle. So if we had a point here, which is some x, y value, then sine is just the y value of the ordered pair. Cosine is the x value of the ordered pair. So when you have x, it is cosine. When you have y, it is sine. And tangent is just y divided by x. So just take your ordered pair and take y divided by x, and that is tangent. Now those are the top three that we're dealing with, but there's also three more, and I have them underneath their respective trig functions for a reason. This function value here is called cosecant, and it is 1 over y. It is the reciprocal of sine. So when sine is y, cosecant is 1 over y. Secant is paired with cosine because it is the reciprocal of cosine. So secant is 1 over x. So when cosine is x, secant is 1 over x. And the last is cotangent, and it is the reciprocal of tangent. Cotangent is x over y. So if tangent is y over x, cotangent is just the reciprocal of x over y. Now you see on a couple of these we have some not equal to's, and those are relevant for the domain coming up. So the domain of trig functions are as follows. Sine and cosine are all real numbers. Tangent and secant are all real numbers as well, other than at pi over 2 plus n pi for any integer of n. This is where vertical asymptotes exist. So before we had not equal to, that is where vertical asymptotes will exist at every pi over 2 plus n pi for tangent and secant. For cotangent and cosecant, it's again all real numbers other than at pi or n pi for any integer of n. Again, these are where vertical asymptotes exist for these two functions. Now, where are these trig values positive and negative? Well, it's easier to know where they're positive than where they're negative, and you can extrapolate from there that if they're not positive, by default they have to be negative. So let's go around the quadrants. Starting here at quadrant 1, all trig functions are positive. So if you're in quadrant 1, all positive. In quadrant 2, only sine and cosecant are positive. That means all other trig functions are negative. In quadrant 3, tangent and cotangent are positive, which means all other trig functions are negative. And in quadrant 4, cosine and secant are positive, and all other trig functions are negative. So a nice way to remember this, a little bit of an easy way to remember this, is the acronym ASTC. And you might have seen in here that I have ASTC in each quadrant. And that just stands for all students take calculus. So all are positive, sine and its reciprocal are positive, tangent and its reciprocal are positive, cosine and its reciprocal are positive. So ASTC. That way you can always know whether it's supposed to be positive, or if it's not, then it's negative. Last, there are some fundamental identities. So we mentioned before, but I'm going to spell it out more clearly. Cosecant is just 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Tangent is just sine over cosine, and cotangent is just cosine over sine. So if you use x, y, or use sine and cosine, it's the same thing. And finally, we have the Pythagorean identities, which are again very important. Sine squared t plus cosine squared t equals 1. Next is this Pythagorean identity, and you can get it by just taking the first identity and dividing every term by cosine squared. So sine squared over cosine squared will give you tangent squared. cosine squared over cosine squared will give you 1. 1 divided by cosine squared will give you secant squared. So this identity, tangent squared plus 1 equals secant squared, is a Pythagorean identity we get from the first Pythagorean identity. And the last one, 1 plus cotangent squared equals cosecant squared, is just dividing the first Pythagorean identity by sine squared on each term to get this. So you don't need to know all three, you just need to know the first one and divide by either sine or cosine squared on each term to get the other two. And of note, sine raised to the nth t, or raised to the nth of t, is just sine t raised to the nth power. So if you have these powers here, if it's outside in a parentheses with the power there, it means the same thing.